everyone. So now we're going to be talking about reflections, and reflections are basically when we do the mirror image either over the x-axis or y-axis. These ones actually are a lot easier than the other stuff that we've been talking about in this lesson. So let's just go over the rules really fast. If we have an original function f(x) and then we put a negative in front of it outside of the parentheses like negative f of x, then it reflects over the x-axis. And if I have f of negative x, or the negatives inside the parentheses, then it reflects over the y-axis. Super easy. When I reflect over the x-axis, all I'm going to do, the x's stay the same, the y's flip signs. And then when I reflect over the y-axis, the y's stay the same, and then the x's flip signs. So the first two examples are asking us to take the equations and then write new equations based on the transformation. The first example says f of x is equal to the absolute value of x, and we want to reflect it over the x-axis. So to reflect it over the x-axis, we know we've got to put a negative sign, obviously, but because it's the x-axis, we want to put a negative sign on the outside of the parentheses, which means super easy. My final answer ends up being gx is equal to negative absolute value of x, because that negative has to go on the outside if we want to reflect it over the x-axis. Now, the next example is f of x is equal to x squared. We want to reflect it over the y-axis. So because we want to reflect it over the y-axis, we're going to look at that rule. Reflecting over the y-axis means that we have to put the negative inside the parentheses. And so we're going to have gx is equal to negative x squared. Remember, when it doesn't have a set of parentheses already or a square root or something like that, you want to set up parentheses for it and then take whatever exponents and put them on the outside of the parentheses. So this is my final answer when I reflect it over the y-axis. G of x is equal to parenthesis negative x close parenthesis squared. All right, for the third example, we need to identify the parent function and then write an equation for the function given the graph. So this one looks really, really similar to the original parent function, but if you look at your table of parent functions on that cheat sheet that I gave you, then you should know that the parent function is f of x is equal to 1 over x. But the parent function, instead of being in the top left and bottom right, is in the bottom left and top right. So I'm going to do it in a red pen. The parent function usually looks like this. Now, this one's a little bit nutso because potentially I could flip those red lines over the x-axis or the y-axis and it would give me what I wanted. So this is kind of like a either or situation. You can put the negative inside the parentheses or outside the parentheses. I'm going to do it both ways just so that you can see. So I can say g of x is equal to negative 1 over x, where that would be considered to where the negative is on the outside of the parentheses because it's not right next to the x. This would be considered a vertical reflection or a reflection across the x-axis. And then if I wanted to do the horizontal reflection or reflection across the y-axis, we'd have h of x is equal to 1 over negative x, where that negative is inside the parentheses. Either of these work, kind of like what we talked about in the last video. Most of the time they will work, some of the times they don't. You want to double check that they will work either way. And if not, that's totally fine. All right, let's look at this last example. And this one is asking us to sketch the graph of the function. So this is f of x is equal to the square root of negative x. So we know that the negative is on the inside of the parentheses, or the inside of the square root in this case. And what that tells me is that I'm reflecting it over the y-axis. So what I'm going to do is start with my parent function, and we'll do it in red as the square root of x. Now I'm not going to put any lines because this one will be pretty easy to see. You can definitely use your lines on your empty graph on your example sheet. So it starts at 0, 0, and then it goes up to 1, 1, and then it'll be at 4, 2. Now, when I reflect it over the y-axis, because that's what it wants us to do, because it's inside, the negative's inside the parentheses, all that tells me is that I still start at 0, 0 because that's on my y-axis, but instead of going up 1 and over to the right one, I go up 1 and over to the left one, and then I go over to the right 4 and up 2. And so it looks exactly the same. It's just on the other side of the y-axis. It just mirrored imaged over. If it had us reflect over the x-axis, or the negative was on the outside, it would kind of look like this. So this is a good example of one where it won't work either way, either or way. It definitely would have to be like, you have to decide whether it's going to reflect over the x-axis or the y-axis. Whereas some of them, like we talked about in that third example, you can do either or and it won't matter. All right, and there we have it. That's how we deal with reflections.